Step into the Coliseum. The Cambridge computer science exams are a brutal arena, and let me tell you, only the prepared survive. Welcome to The Explainer. I'm your host, and today we are looking at a strategy masterclass, Gladiator Enter the Arena. We're talking Cambridge exam strategy. Let's dive right into this because the clock is ticking. Imagine a real Cambridge computer science past paper question, specifically from syllabus code 0417. Consider our two students standing in the arena right now. On the left, we have Alex. Alex has practically swallowed the textbook. Alex has memorized every single computer science fact available. Alex knows exactly what base 2 is, what a register is, what hexadecimal means. But look at the answer Alex actually writes down. It's just a raw dump of facts with absolutely no analysis. Red pen marks everywhere. Totally brutal. Now on the right, we have Sam. Sam genuinely understands the concepts, but always rushes, completely missing the crucial command word requirements. Sam wrote, "It's faster," without explaining why it's faster or how it actually works. The result? More red marks. Listen, mastering Cambridge computer science exams, whether you're taking 0417, 0478, 2210, or 9618, requires far, far more than just surface-level memorization of binary and denary definitions. The timer is ticking, the pressure is on, and today we are going to fix exactly what Alex and Sam are getting wrong so you don't make the same mistakes. To get you surviving and thriving in this arena, we need a disciplined battle plan. Here is our roadmap for today's explainer. First, we will move beyond simple vocabulary. Second, we'll explore the 3 layers approach. Third, we'll tackle the massive difference between describe versus explain. Fourth, we'll build a structured solution path. Fifth, we'll learn to avoid common errors. And finally, we will arm you with the 4-question check. Section 1. Beyond the vocabulary list. Let's start by totally debunking a common studying myth that traps thousands of students every single year. Consider this brilliant insight from our source material. Students usually retain the topic much better when they understand the reason for the concept instead of meeting it first as a vocabulary list. This is exactly where our student Alex from the intro went completely wrong. Memorizing that binary consists of ones and zeros, or that denary is base 10, will absolutely not get you full marks in the exam arena. You have to understand the specific digital problem it actually solves. The examiners are not looking for a human dictionary. They are hunting for a problem solver. Think about it. Why was binary even invented in the first place? It's because computers are built from billions of microscopic transistors that act as tiny switches, and a switch only has 2 possible states, on or off, high voltage or low voltage, a 1 or a 0. If you don't understand that foundational reason for the concept, you're just reciting words you don't truly grasp, and the examiners will spot that weakness immediately. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so the crucial point here is grounding this abstract theory in reality. Take a look at these practical applications: phones, websites, databases, automated systems, banking, and robotics. This is how we convert rote memory into actual scorable usefulness. Let's take automated systems, for example. In a Cambridge exam, you might get a question about a microprocessor controlling an automated factory greenhouse. You need to know that the sensor sends analog data, an analog to digital converter transforms it to digital binary data, and then the microprocessor compares that binary data to a stored binary value in its register. If you just define the word binary, you get 0 marks. But if you can explain how the patterns behind binary and denary appear in that specific robotic scenario to trigger a water sprinkler, you are suddenly thinking like a top-tier student. Section 2, the 3 layers approach. We need a systematic way to level up your answers from basic to advanced. The blueprint for this transformation is the 3 layers approach. Step 1 is the simple explanation. This is where you explain the concept like you would to a friend using everyday language. Step 2 is the technical explanation, where you add in the correct, precise subject vocabulary, words like registers, hexadecimal, logic gates, or data packets. But step 3 is where the real magic happens, the exam explanation. This is where you shape that technical knowledge to score marks under immense time pressure. A lot of students falsely believe they know a topic when they are only resting at layer 2. They step into the exam, panic, and completely fail to execute. To reach layer 3, top students use a framework called PEL. That stands for Point, Evidence, Explanation, Link. Make your point, back it up with technical evidence, give a clear explanation of how it works, and link it back to the specific context of the question. I want you to actively look for this PEL structure as we keep going. Spotting it is half the battle. If you can master layer 3, you master the exam. Section 3. Describe versus explain. This is a critical distinction that Cambridge examiners are constantly looking for when awarding marks. Misunderstand this, and you bleed marks. Let's compare the command words describe versus explain. To describe simply tells what the device, process, or method is. To explain tells exactly how it works and why it actually matters. Remember our student Sam from the beginning? Sam rushes everything. When a past paper question asked to explain how a MAC address is used, Sam just wrote, "It is a 48-bit hexadecimal number used for network identification." Guys, that is a description. Description alone is safe, sure, but it is incredibly shallow. You will max out at 1, maybe 2 marks if you're lucky. To truly explain, you need to tell the examiner that the MAC address is assigned by the manufacturer at the factory, that it operates on the network interface card, that it ensures data packets are delivered to the correct specific device on a local area network, and that unlike an IP address, it does not change when the device moves to a different network. Do you see the massive difference there? Description is just pointing out the pieces on the chessboard. Explanation is showing the examiner exactly how you plan to achieve checkmate. You want to see those red pen marks transform into green check marks. Section 4. The structured solution path. Now, let's pivot to the highly technical step-by-step method for structuring those high-scoring exam answers. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's dive deep into this sequence because this is where the real transformation happens. Think of this as an interactive workshop. Step 1. Identify the question demand. You need to scan the data, look at the prompt, and find the command word. Is it asking you to describe, explain, compare, or evaluate? Step 2. Classify the correct concept. Are we talking about memory versus storage, compilers versus interpreters? You have to pin it down immediately. Step 3. Explain the sequence step by step. Many computer science topics are entirely process-based, which means the order absolutely matters. If you swap Step 2 and Step 3 of how a laser printer works, the whole answer collapses. Step 4. Connect to the context, providing a specific advantage, disadvantage, or a design choice. This discipline sequence is our computer science success blueprint. Now imagine a 60-second timer on your screen. You have to read a complex chart, find the flaw in a sample paragraph, and rewrite it. Think back to Alex. By applying this exact 4-step path, Alex stops dumping random, disconnected facts onto the page and instead produces a tightly woven, logical narrative that directly answers the specific prompt. It completely eliminates the panic of staring at a blank page when you're under pressure. The absolute golden rule of Cambridge exams is this: context is king. I literally cannot stress this enough. Generic, copy-pasted textbook responses rarely gain full marks. If the examiner sets the question in a school office, your answer must talk about students, teachers, or school records. If it's set in an industrial manufacturing system, you must talk about sensors, machinery, or continuous data monitoring. Leaving your answer floating in some abstract theory zone is a guaranteed way to lose precious marks. The answer must always stay locked inside the specific real-world scenario set by the examiner. If you had 30 seconds for a speed writing challenge right now, and the prompt was about a hospital database, your PO paragraph better mention patient records and doctor access, not just generic users and files. Section 5. Avoiding common exam errors. Let's shift our focus to an error-aware approach. Knowing what to do is only half the battle. The other half is identifying exactly where students needlessly bleed marks. There are several extremely common pitfalls you must avoid: vague wording, confusing similar terms, missing sequence steps, stating advantages without reasons, or ignoring the context. For example, if a student writes, "Binary is better because it's secure," they are stating an advantage without giving a reason. Binary itself isn't inherently secure without encryption. That's a huge error. Or consider solid-state drives in laptops. If you just mention that SSDs have no moving parts, but you completely fail to link it to the context of a laptop being easily dropped while traveling or needing low power consumption for better battery life, you drop the marks. Mixing up general theory with contextual examples completely breaks the logical flow of your answer. You have to be precise, you have to be specific, and you must justify every single claim you make. Section 6. The 4-question check. Let's look at a highly practical self-verification tool to guarantee your exam readiness. If you can pass this check, you are ready for the arena. This is the first crucial self-prompt. What is it? Can you accurately paraphrase the core mechanism without relying on a memorized string of words from the textbook? If the topic is an IP address, can you clearly explain that it's a unique identifier assigned by an internet service provider to a device connecting to the internet? If you just rely on repeating internet protocol, you don't really know what it is. You have to be able to define it in your own clear, confident terms. The second prompt challenges you to logically sequence the process steps. How does it work? Computer science is all about mechanisms and systems. If you are asked about a denial of service attack, you can't just vaguely say, it breaks a website. You need to sequence it accurately. A malicious actor floods a server with useless traffic, the server becomes overwhelmed processing the fake requests, and as a result, legitimate users are unable to access the service. Sequence is everything. Let's hit the third prompt. Where is it used? This verifies that you can actively transfer the theory into a realistic computer science scenario. Remember, context is king. If we're talking about hexadecimal, where is it used? It's used in MAC addresses, HTML color codes, and memory dumps. But why? Because it represents large binary numbers in a much shorter, more manageable format, which reduces human error when programmers are typing it out. And the final prompt confirms your ability to evaluate. Why is it better or worse? In an exam, you'll constantly be asked to justify choices and evaluate alternatives. Why use optical storage instead of magnetic in a certain scenario? Why use a compiler instead of an interpreter for commercial software? You must be able to weigh the advantages and disadvantages specific to the situation. This ties our whole system together: command word decoding, the Peel framework application, and our time management matrix. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here is my final challenge to you. Can you answer all 4 of those questions aloud for every single topic on the syllabus? If you can verbally answer those 4 questions, you are a gladiator ready to conquer the exam arena. If not, what are you waiting for? Get back to the revision cycle. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.